Hello everyone. And today in this lecture we will discuss about the techniques of Turing machine, modification of Turing machine and what are the string acceptance. So, here technique of the Turing machine, how this Turing machine move left, right like that, sometime it is stay, and for the some algorithm is there how to design this algorithm technique for this Turing machines, and already we have seen some Turing machine design in numerical, and here is the modification of Turing machine means we have to modify the Turing machine and some variant of Turing machines are there. Variant of Turing machine means different kind of Turing machine that is also equivalent to Turing machines. So, this we have to modify something like that. We are standard Turing machine, we have only left and right move. So, you have to modify that Turing machine, suppose we have to stay on some position, stay on the input alphabet. So, we do not have to move the head. So, this is one kind of modification. Sometimes we have to, there is no option, we have to write something there, each and every input we have write something. So, there is many variant of Turing machine, we will go for that. So, already we know this Turing machine, we have 7 tuples, the capital Q input alphabet, tape symbol, del is transition function, Q 0 and this B is the blank symbol and F is the final state. So, Q is the finite, already we have all this study all this completed in previous lecture, and transition function that already we know, left shift, right shift, how to move left, move right, we have already seen, and B is the blank symbol, F is the final states. So, what is the need of modification? What is the need of the modification? Why modification is there? Why Turing machine modification? That technique already we have seen how to design in Turing machine, some numerical we did in last class. So, here modification of Turing machine. See, modification standard Turing machine we are, which head can moves either left or right, or it may overwrite existing input. We have writing option, we can write something there in the tape. So, we can do some kind of modification, increase the number of language accepted by the Turing machines. So, there is some option we can have modify some Turing machine, maybe this will be accept number of, increase the number of language accepted by the Turing machines. So, we have different language, we will go for that in later on. So, how this is, we will modify some Turing machine and how this is accepted. We have also deterministic Turing machine, non-deterministic Turing machine, multi-tape Turing machine and single tape Turing machine, like that many variant is there. So, we will go to one by one. So, see what is the modification of Turing machine? Turing machine with stay option, Turing machine with stay option. What is the meaning here Turing machine with stay option? Means we have Turing machine, in the tape we have some input alphabet. So, head is point to a single point and you have to stay there, whatever you modify it and you have to stay sometime there. So, we do not have to move the left or right. So, Turing machine with semi infinite tape. What is the meaning of semi infinite tape? So, already we have studied in Turing machine that our tape is infinite. So, we both side of blank. So, blank can be replaced by some input and that can be goes to that goes to infinite. So, here it is saying that semi infinite. What is the meaning of semi infinite? Semi means you can say semi decidable, partially infinite, you can say semi infinite. Semi infinite means one side of the tape you have to make it finite, only you have to move, there is option one side you can goes to infinite, other sided you have to make it finite. So, this is called Turing machine with semi infinite. So, one side you have to, we will go to its diagram, we will go by step by step. So, Turing machine with semi infinite tape means you have to fix one end with finite and other end you have to move infinite. So, you can choose any one of these, you have two end, either you can take left as a infinite or fix right as a finite, or you can take right as a infinite and left as a finite, like that you can fix it. So, another is offline Turing machine. So, in this offline Turing machine is different kind of Turing machines. We have some input and input with output is there, input with output is there, and input what you have to do, you have to change something, then what you have to do, you have to take the copy of the input to different tape and change there only. So, this is the offline Turing machine. And non-erasing Turing machine, this non-erasing Turing machine means we have some input alphabet is there, we have some input alphabet is there, in input alphabet we have some input and including blank symbol, you could not erase the symbols, there is a option to you can erase the blank symbol, but you could not erase the input alphabet. So, another is jumping Turing machine, jumping Turing machine. This jumping Turing machine, what is that? So, already we have checked the in standard Turing machine. Standard Turing machine is saying that we have to move the cell one by one, one by one. If one head is point to one cell, then it will go to the next cell, either it is left or right. But it is saying that you have to move jumping, you can go jump like a 2 3, skip 2 3 position and jump there, and like the left or right. Okay. This is the always writing, then another is always writing Turing machine. This always writing Turing machine means you must have to write something for each and every input, for each and every input you must write something. This is the always writing Turing machine. We could not skip, we could not read and move left or right, whatever input alphabet is there, you have to write something there, either you have to write something and move left or right. So, we will go to one by one with the diagram proper. So, these are the variant of the Turing machines, you can say modification Turing machine or you can say variant of Turing machines. So, now Turing machine with stay option. So, what is the stay option? What is the Turing machine with stay option? Turing machine with stay option, what it is the diagram? See here, Turing machine with stay option. With this is a kind of theory topic with stay option, this is stay option. All the topics are, this is a kind of theory topics, stay options. Okay. So, we have some input like that, this is the, so suppose A, B and this is A and B like that given. So, you have some Q0. So, your head will be stay, I have written here, suppose Q0, this is A and goes to Q1 and this is B and S. This means your input A will be replaced by B and you have to stay there, your head will be stay here only, you could not move anywhere. So, now this is B, B, A, B, this is Q1. So, head position is remain same, we could not move, stay there. So, some kind of numerical is there, we have to require to stay there. So, this is the stay option, means no need to move left or right, you whatever option, either you read it or you have write something or like that you do it and stay there, you do not need to move anywhere. So, this is the Turing machine with stay option. So, now we have Turing machine with semi infinite tape, Turing machine with semi infinite tape. So, Turing machine with semi infinite tape, you can see Turing machine with semi infinite tape, Turing machine with semi infinite tape. So, already I discussed that you have to fix here one end and make infinite to other end, make infinite to other end. This is the saying that Turing machine with semi infinite tape, Turing machine with semi infinite tape. Turing machine with semi infinite tape. So, this is a theory kind of subject. So, Turing machine with semi infinite tape, semi infinite tape. So, here you can say input tape is there. So, you have to fix one end. Suppose this is the input, we have to fix it, and this side will be maybe infinite. So, this is we could not move this direction, this is fixed, this is fixed. So, here we can move, suppose your head is here, suppose q0 head is here, you maximum go to this one is the maximum, this is the max, you have to move, and this side you can go to infinite, this is the infinite tape. So, this kind of some Turing machine we need that we do not require to move one directions, we have no need to require both direction go to infinite, we can make it finite. So, this is the Turing machine with semi infinite tape. Semi infinite means we have to make finite, one side is finite and we have to fix it and other side make it infinite. So, this is one kind of Turing machine, and offline Turing machine you have to copy your input, you have to do it copy the in another tape, and you during offline you can do this. And this non-erasing Turing machine means we have to erase the input, this is not required to do the diagram, we have to erase the non-erasing Turing machine. Non-erasing Turing means input you could not have erased. So, blank can be erased, blank you have to write erase something, blank can be that you cannot erase the input alphabet. So, another is jumping Turing machine. This jumping Turing machine means like that, suppose we have jumping Turing machine, we have some Turing machine, let me draw the diagram. This is the jumping Turing machine. Jumping Turing machine, this jumping Turing machine. So, here suppose we have a input alphabet like that, suppose A, B, an example A, B, B, suppose Q0 is there. So, can be jumped to, I can say it can be jumped to like that B, B, and this is A, this is B and this is B. Suppose Q1, let us jump to the here Q1. So, like that you can jump to after like that, here it is after 2, like that you jump to Q0, this is Q0 was here, then after that you can go to Q1. Similarly, suppose here is the 3 jumping or 2 symbol in between that, again after that suppose like that B, C, B, like that input is there, then again it will be jumped to here like that Q1 or Q2 any state you can jump like that. So, this is the jumping Turing machine, no need to be go by the cell by cell, this is the jumping Turing machine. So, jumping Turing machine. Then next is always writing Turing machine, always writing Turing machine. This is the always writing Turing machine, always writing Turing machine. So, you have given a tape, is given to you, always writing Turing machine. How this work? You have some Turing input alphabet A, B, A, B, B. So, for each input you must have to write something, each input you have to write something. Suppose we will here Q0 and you have to write, compulsory you have to write something. Suppose this is X and B, A, B, B. Suppose this is Q1, I replace writing, then Q1, suppose I write something and go to B. So, each input of the tape will be replaced by some other input. You must have to always writing Turing machines. For every input you have to write something. So, you can say whatever we did in last lecture, one example we did this one, A is A to the power n and B to the power n. No, this is not, you have to all input, when you will read the input you must have to write, because here we are writing x and y, A to the power n and B to the power n, that is at the end we are writing something. But here it is saying that when you will read input, on that time you write and go ahead. Suppose I will ask you do the complement of a binary number, complement of a binary number. So, what you have to do? Complement of a binary number. Suppose 1s complement, you take an example here, 1s complement of a binary number. What you have to do? 1s complement of a binary number. Already we know what is 1s complement of binary number. 1s complement. 1s complement is saying that, 1s complement is saying that you have to take 0 or 1 as a input alphabet, and you see this is a 1 0 1 0 1. So, 1s complement of this, 1s complement will be, 1s complement will be, this is 0, this is 1 and this is 0, this is 1 0. This is the 1s complement of a number. This is a binary number given, binary number. We have to make it 1s complement is, you have to negative it. If 1 is there, you have to 0 and 0 is there, you have to 1. So, let us do this one. How to do 1s complement? This can be, you can say this is a always writing Turing machine, always writing Turing machine. So, let us check how this will be done, always writing Turing machine. So, your input is, I have taken input C here, this is Q0. So, now if you read 1, then replace it to 0 and write, then 0 you have to replace it 1, then write, then this is blank and you can replace nothing, go to blank and then you replace blank by blank, no problem, and go to the QF final state. This is right. So, you take input alphabet here, take a input alphabet, this input alphabet is given 0 1 0 1. So, 0 0 1 0. So, 0 1 is 0 is the input alphabet, 0 1 0 is the input alphabet. Now, you check Q0, you have to consider the input alphabet to replace it, blank do not consider. So, all input you have to check, replace it. So, Q0 0, you see if Q0 0 is there, then 0 replaced by 1 and move right. So, your tape will be like this. This is 1 and this is 1 and 0. Now, see this is q 0. Now, q 0 point to 1, q 0 point to 1. When q 0 point to 1, you see the diagram, your head is point to 1 now, this 1 is replaced by 0 and move right. 1 is replaced by 0 and move right. So, again what you have to do? So, here it will be 1 and this is 0, then this is 0 and q 0 point to 0. Again q 0 point to 0, you have checked there when q 0 input is 0 and 0 replaced by 1 and move right, move right. So, now this is what will be the tape? The tape will be 1 0 and this is 1. Now, this is blank, we know that empty means blank, empty means there is nothing, means you have to consider this is a blank. So, q 0 point to blank, point to blank. Now, q 0 your head is point to blank and you check it, if blank is there then go to the final state. So, this is the acceptance, or you can say here whatever input tape you have already you have converted into 1s complement and you write all input and make it 1s complements. So, some like that you can do 1s complement, 2s complement and many numerical you can do like this one in writing option, writing always writing Turing machine, and some numerical is there you have to use the writing tool machine like the 1s complement. You see every input you must have to change it, you have to must have to write something, that is why this is the always writing Turing machine, always writing Turing machines. So, similar ways you can do the 2s complement, you can do the 2s complement of this Turing machine, 1s complement, and it is not that you have to always use the always Turing always writing Turing machine. So, maybe other kind of Turing machine, standard Turing machine you can have like the addition of 2 number and subtraction of 2 number, multiplication of 2 number, a to the power n also we can find out like that. Some whatever computation, whatever arithmetic operation, for that we can have also Turing machine. So, we are not doing much of that. So, you can do also. So, these are the variant of Turing machine. So, also there is a another thing, we have finite automata and we have to deterministic finite automata and non-deterministic finite automata. We have deterministic push down automata and also non-deterministic push down automata. Similarly, we have deterministic Turing machine and non-deterministic Turing machine. So, here some different is there, this equivalent of finite DFA and NFA both are equivalent. If a language is there, regular language is given, we can have deterministic finite automata, we can have non-deterministic finite automata. But this is in PDA, if a language is given, for that we can have non-deterministic finite automata, but we cannot have deterministic finite automata like the polyandrome of any string like WWR. Suppose this language L W W to the power R, this W belongs to A B asterisk. This cannot be designed by deterministic push down automata. For this we choose the NPDA non-deterministic push down automata, because some language is there that is accepted by, that will be accepted by the non-deterministic push down automata, and some language is there that is accepted by the deterministic push down automata. So, that is why DPDA, NPDA are not equivalent. Sometimes in competitive exam question came like that, it will be ask you finite automata and NFA, DFA are equivalent, PDA, NPD are equivalent, deterministic Turing machine, non-deterministic Turing are equivalent. So, which one will be false like or true, it will be asking you. So, here finite deterministic finite automata, non-deterministic finite automata are equivalent, but push down automata, deterministic push down automata and non-deterministic push down automata are not equivalent. Some language is there, we must have to go for the non-deterministic push down automata. We could not have deterministic push down automata at all. So, like that this example L example here L W W R, we must have to follow the non-deterministic push down automata. So, similarly, we have deterministic Turing machine, non-deterministic, but these are equivalent. We can, if a language is given, we can have deterministic Turing machine, we can have non-deterministic Turing machine. These two are equivalent. So, this question came in many times in competitive exam. So, this is one question example, which of the following statement is true, which of the following statement is true, which statement, this example is given. See, every multi-tape Turing machine has equivalent single tape Turing machine. This is very true statement. How this one? You have like that multi-tape is there, here multi-tape is there, you can say this is multi-tape is there. Just I am saying one concept, if you know that you have you know that two dimensional array or in C language, but it is stored in a one dimensional array, it is stored in a contiguous array, but it work like a one dimensional array. Similarly, here you can say tape 1 and this is tape 2 and this is tape 3. So, like that you can make it a single one T1, T2 and T3, like that you can make it, make a single tape Turing machine. So, these are option A is true, we can make a this multi tape equivalent a single tape Turing machine. Which of the following does not exist? So, this is asking that Turing machine with multiple head, Turing machine with finite tapes, Turing machine with two dimensional tapes. So, all three are existing. So, it is asking which of the following does not exist. So, this means we have multi-tape Turing machine, we have Turing machine with infinite tapes, Turing machine is two dimensional tape we have. So, but it is asking that does not exist. So, here D is the option, D is the right option, none of these. So, these all are existing, all are existing. So, there are many questions, theory type of question in this content in your competitive exam. You will see the GATE and NET exam, and this theory type of question little bit conceptual, you will go for all this detail, then you can do it. So, these are the reference book. Thank you so much.